video I will show you how to plot multiple graphs on a display surface using normalized device coordinates. To introduce the project, I will now present some slides. This is video 5, graph drawing using NDC. The output from this particular project is shown on the right hand side here. I introduced the concept of NDC in video 4. What NDC does, it makes the display surface appear to be 0 to 1 to the user, regardless of the actual screen resolution. The problem we have is, how do you present engineering or real-world data on a graph surface? In this particular example I'm going to run through, graph plotting is an automatic function, and data is held in two arrays, x and y, and you plot lines between points on the surface defined by the x and y array. X min and x max and y min and y max are values that can be determined by scanning across the array. The range is the difference between the max and min values for both arrays. If you subtract x min from all the values in the x array and the same thing in the y array, it means that both arrays have a minimum value of 0 somewhere in their set of numbers. If we divide all the values in the x and y array by the range value, the maximum value in both arrays will be 1. This means that the minimum value in each array is 0 and the maximum value is 1. And as the screen dimensions of NDC is 1, this would mean that a graph could be drawn to fit the array. However, you also need to add axis information and titles, etc. And what we're going to do now is we're going to multiply all the values by 0.3, and this will reduce the size of the graph that we're going to plot. And if we wish to translate the graph into a new position on the screen, we can do this by adding 0.1f to both the x and y arrays. And the result is this. We've now positioned the graph here in this location, and it's been scaled to fit in that area, and the border is 0.1f all the way around. Okay, and if we wanted to move it further up here, say into that region, we would just have to add on 0.5 to the y value or 0.5 to the x to get to that position. So in this way we could plot multiple graphs on the display surface. The automatic function is useful if the user wishes to view the shape of a plot. But if you consider the case where we might have x min 55 and x max 96, it may be more convenient to use these values 50 and 100 and to divide the axis into little blocks of 10. So the manual plot function allows the user to set the limits to the x and y axes. In the graph plot object, there are three methods of plotting. There's the automatic plotting, which allows you to observe the shape. It doesn't necessarily set up the axes satisfactorily. Manual, where you have control, and incremental plotting, where, for example, you might plot the output from an algorithm as it runs iteratively. The GA example in video 2 uses this particular type of plotting. Here we have the three types of plotting listed. If you notice that these two functions have the same name, and this is an example of overloading. In the next slide I will look at scale and translate. The model fill array holds the data for the sine wave with exponential decay, and that's the function we plot. And for NDC, coordinates refer to video 4. Plot frame. This is an event handler, and in this block of code we've got three objects created, and we load an array These are the numbers after they've been scaled and translated. This is here's the translation, where you set the factors, offset and factors, right? And you can plot 3 graphs, and here's an example of plotting a graph, plotting graph 1 of the 3 that are available. Here what we've got is the translate function, where we're adding an offset to every element in the array, and here is the scale function, where we're multiplying every element by a scaling factor. In the earlier example, this was 0.3 and that was 0.1. I've loaded the plot graph project into NetBeans. We'll run it here. And you can see there are 3 graphs plotted. I've used rectangles to mark this graph. No markers here. Okay, we'll now look at the graphs object. If you look at the graph object, here we've got the plot graph 1, plot graph 2, and then the third one with the incremental plotting. So these functions set up all the various, they get the min, max, normalize it, scale it, translate, and then plot. If we go to the model, we can see this here. This is the function that's being plotted, and for various values of x coming in, these are the y values. This is a decay, a sign with an exponential decay. Here we've got the draw line feature inside the normalized graphics, floats feeding in, and we're drawing a line. As I said previously in slide 3, slide 4, this is actually, this little bit of code inverts the y-axis. Plot frame. So here we're getting the panel dimensions, and then setting up the normalized device system. Right then down here we're creating 3 graphics objects. Graphics object 1, 2, 3, and then giving it the normalized graphics variable or object. And further down here we're putting in the array values and plotting the same array but in different locations. Here we've got scaling factors coming in. These scaling factors are set at the top of this block of code, adding access information. And down here we've got plotting the 3 graphs. These 2, in fact, they're all using the manual approach because I've defined the axis dimensions in each case. I think that completes everything. I hope you found this presentation interesting. Bye bye.